Hi, this video an overview for my project. My project is a car park. Finding a car park slot is becoming very challenging. I'm trying to help customers with this task. Also, I'm trying to help businesses who are administering car park. They may need reports that show daily or monthly or even yearly the status of their car park, their car park slots and its availability. If they wanted to monitor a specific car park slot and know when it's occupied. Let's go each part of my project bit by bit. I'm gonna start with the LCD, which is outside of the car park. It shows a welcoming screen to the people who are coming to the car park, and also it shows the availability of the car park slots that are available inside the car park. This LCD screen is talking to the Raspberry Pi through I2C. So the data is coming from the car park into Raspberry Pi and then I2C to the LCD. The first part of my project is the gate. It consists of IR beam brake sensor. So once a car exists between this car park IR beam brake sensor, it breaks the beam, which sends a signal to Raspberry Pi. The Raspberry Pi then sends a signal to the servo motor in order to open the gate. Opening or closing the gate is done through PWM. Changing duty cycle is opening and closing the gate. Changing duty cycle is helping with changing the angle of this servo motor. Once the car passes the IR beam brake sensor, Raspberry Pi sends another signal to the servo motor in order to close the gate. The next part of my project is the flow or the car park. It consists of 7-segment display which show how many car park slots is available. As you can see, there is 3 car parked and 2 car park slots is available. Each car park slot has its own obstacle avoidance sensor. If the car is reaching this obstacle avoidance sensor, it sends a signal to the Raspberry Pi. Raspberry Pi sends a signal to the LEDs above the car park slots. It puts the green light into low and red light into high. At the same time, the 7-segment display is showing 1, and also the LCD is updated to show 1 space. All the data from obstacle avoidance sensor is collected and sent to the Raspberry Pi. Raspberry Pi then sends this all data through I2C to Particle Photon. Particle Photon is responsible for all the cloud part of my project. It publishes all this data into the cloud, as you can see. So each car park slot has its own state, which is 0 or 1. 0 means available, 1 is occupied. Also, I have created 4 channels in the ThinkSpeak. Unfortunately, I'm allowed only to create 4 channels. So I used 2 channels to 2 car park slots. The 3rd channel for how many cars is parked in our car park. And the 4th channel is about available car park slots. So if I open the parked cars, this will show a graph of how many cars are parked in our car park over time. This will give an idea of the capacity of the car park to the business who are administering the car park. Also, if the business wants to administer or monitor a specific car park slot, they are using IFTTT. So once a car is parked in a specific slot, say for example slot number 5, the status of the slot is changed from 0 to 1, which is gathered by Raspberry Pi, sent to Particle Photon through I2C, and then publish data over the internet onto the cloud. Once the status of the cloud variable changed from 0 to 1, it's a trigger for IFTTT to send an email to the people who are administering the car park in order to know that there is someone parked in this car park. And this is an example of the email. So it says car state cross our threshold, or report that slot state has been changed and become 1 now. The other part of my project is using an application called Blink. Blink application is helpful for the businesses who are administering the car park. So instead of going to the car park in order to know the status of each car park slot, they can use this application. As you can see here, each car park slot has its own LED to show it's available or not. So slot number 1, number 3, number 4 is not available, and the slot number 2 and 5 is available, as you can see. Also, they can reserve a specific car slot by clicking these buttons beside the car park. So if, for example, number 2, so if they click the button, it changes the LED from the green to red. This will help reserving a specific car park slot for a customer until he go and park in this area. And once the customer has finished parking and go from this car park slot, it's come back to green. The buttons in the application in the bottom, it's about controlling the gate, one for entry and one for exit. And once they click any buttons of these ones, it will control the gate and open or close the gate. Going down to the gate, if I click the entry button, this will open the gate and close it back again. And if I press it and keep pressing, this will open the gate. It will not release it until I take my finger off. Thank you.